Right. Any ideas? Why do we want to solve a quadratic equation? That's what we do. It's not why. But I will write it down. We're going to find the roots. But why would you want to do that? Why do I want to solve any equation? Say it again. Well, no, because that solving it gives me one value or two values for x. So I could when you say plot it, what do you mean then? So you're solving it to find the roots so that you can put those two on the graph so you know what it looks like. Is that what you're saying? Okay. Well, actually, if I've got the function, I can just put lots of values of x in um, and find those values anyway. I don't need to solve it to do that. So for instance, if I've got y equals 2x squared plus 3x minus 6, I don't need to solve 2x squared plus 3x minus 6 is equal to 0 to find where they cross and then plot. I could just put x values in and see what happens. Yeah, just and draw the whole graph if I like. It does find those 2 points, so I'll give you that. But why? What would be our reason for doing it? It's this question, guys. Why? I know you hate it when I ask, but it keeps things in mind. So fundamentals, guys, why do you set up equations in the first place? Solve. Basically, we want to solve a problem, right? So you solve for something, like you said, but we're solving a problem. Now, finding the roots, for instance, like you've said, might be part of solving that problem. So could you give me some situations where those roots would be part of solving a problem? Come on, ATLs, guys, thinking. Bit of critical thinking. What have I been doing and why have I been doing it? What are the problems that we can actually solve with this stuff? Yeah. In what context? Yeah. So, why? If do you remember the problems that you had where you had some fencing? Yeah. So if we lay some fencing out and we had a river on one side, okay, we could find some lengths. Right? We could find some lengths. Um, why, by the way, does that end up as a quadratic equation?
Vary how much, or you can vary each side length. And then
You can, but that could end up as a linear equation as well, Neil. So what information was I given, or you given, which meant I'm going to end up with a quadratic equation? Sorry, what?
x squared, so like you have something with area.
Yes, That's what I wanted. Yeah, you were given area. Okay. If I was given length, I would end up with a linear equation to solve. But because I'm told area, I end up with a quadratic. Okay, because we've got something multiplied by something else. So do you remember the A and the B, and the area would be A times B. Okay. And this leads us to being able to use our null factor law. So when I do use that and I find these two roots, what does that tell me about the field? It's important not to lose sight of this, guys. Why am I doing it? So, for instance, if I do the area of a field, actually this point is going to be here, and I'm going to end up with a parabola that does this. What is important about these 2 points? What does it tell me about the dimensions of the field? Well, not just the length, but three letters, one word. Yeah. So that would be the maximum length x could be, and this would be the minimum length x could be. And what about this point in the middle? What's it called up here? It's the vertex, and that would represent the maximum area. Okay, and we would find that because it's, what's that line called?
Axis of symmetry.
The axis of symmetry. Yeah, no. It's not an asymptote. No, right, definitely not an asymptote. Because an asymptote is a value that will never be given, whereas this is the maximum it will be. It will be that value. All right, so we can find our roots because that, and remember, listen to the words I say. If we find our roots, we can then, if we find our roots, we can then find the vertex, which is the maximum area. So we're solving this problem for what is the maximum area that I could have. So being able to solve for the roots allows me to do that, right? And there are lots of problems like that. I don't know whether you did another one, but if I have a sheet of card and I'm going to fold it up to make a box, okay, it's made from a sheet like this, but you then cut out squares from the corners. All right, those are the variables, the size of those squares. And I could ask you, what is the maximum volume, for instance, of the box? All right, so that's another problem that would be solved in the same sort of way. Right, we could end up with a quadratic in that. Right, so we want to solve quadratics for a reason. There was something else that we did as well, or you did, with quadratics. Remember the word modeling? Because that was modeling, but we also did other things, such as what? Okay, you did this. You spent weeks doing modelling. What did you model? You can't have forgotten it. You are just not talking to me. Well, we used parabolas, but what did we model? What were the things that we did? Bridges, yeah. We had modelling the bridge. All right, do you remember we had kind of the shape of the bridge, the cables, yeah. All right. Now, if I were to take the models that you did for this parabola and I tried to solve your ax squared plus bx plus c is equal to 0, I'd be trying to find where the cable was below, all right, the road length in this model. And what would you then tell me?
Minimum height of the cable is like at the road.
Okay, so, well, let's say in my diagram, because we did it, it's slightly above. So if I asked you to solve this, whatever it was you came up with, like 0.009x squared plus 0.06x plus 11, if I asked you to solve that, what would you tell me? Yeah. There are no solutions because this line does not go through, all right? Which is why I said it was very important that you define what your variables are, okay? You must say, because it has a meaning then, what the y value and that kind of thing is. All right, something else that we also mentioned where we talk about why we might want to consider the roots was that piece of work that you did. All right, what do we have here? The basketball. So remember we talked about projectile motion, and we're going to have a little chat about what's going to happen regarding your assessment in a bit. Hopefully we've got time. All right, projectile motion. Now, what does a root of this quadratic, so that'd be like minus ax squared plus bx plus c, what will that root tell me? If it's not a basketball this time, but let's say I'm just throwing a ball and it lands, what will this point tell me?
Or how far away it went.
Yeah, this could be the distance traveled. So I would want to find the roots so I could find the distance traveled. Okay. Now that's if the x-axis is a distance axis, but there are times as well where I can plot and model where it is a time axis as well. So it could, not as well, but instead of distance, it could be time. So this would be where is the ball for a given time. So this would be the time in the air. All right. But again, the roots tell me these things when I'm modeling. So I just wanted to refocus you a little bit because we get stuck into how do you solve and forget why do we solve. Now they're really, really important because the roots of a quadratic have meaning, right? They have meaning when we are doing our modeling, all right? So that's why we're doing them. All right, so let's have a look then at the next phase though. So what we've got so far, we've looked at trying to solve through factorization. If it didn't solve through factorization, we solved using the vertex form, okay? Now, you've all told me these two are good for you. I can give you any question on those and you'll be able to do it, all right? Now, I told you that coming from vertex form, there is another option, which is using the quadratic formula. Did anyone have a look at how vertex form ends up being the quadratic formula? No? Okay, won't dwell on that. I'm not going to go through it unless someone actually asks for it, because it's, you know, it's a bit of a challenge for those people that like mathematical challenges. I thought I had a couple. But I'm not going to do it because it's not necessary at this stage. But all we need to know at this stage is how to use it. So remember again, with a quadratic, we're looking for finding the roots. We need it when the function is equal to 0. So that's when the y value is equal to 0. Just recapping. So same thing as when we factorize. We've got the sort of x plus h and the x plus k, and we know the solutions. All right, or we've got the a x plus h squared plus equals 0. So the quadratic formula is the same thing, but quadratic formula allows us to just go straight from standard form. All right, so we don't need to do any rearrangement. Okay, does that make sense? Yeah. Okay, so this is the progression. We've just got another option. So does anyone remember the quadratic formula? Okay, so that's the quadratic form. You'll notice that I put x equals, and a lot of people forget to write that because they go, oh, what is the number at the end? Remember, this is coming from vertex form, and it's to give us our two solutions. So we're going to end up with x1, the first solution is going to be negative b plus the square root of b squared minus 4ac all over 2a. And the second solution is going to be negative b minus the square root of b squared minus 4ac over 2a. Okay, so that's what we're doing. There are two solutions. So the quadratic formula is that. All right. Do you all know how to use it?
I think I need a little bit.
Okay. Do you all know what the A, the B, and the C are in it? Yeah. Well, I'll tell you what, I'm going to pick one of these examples from practice 5 that you're going to work on. I'm going to do this one here, E. All right. So we've got, so E is, we're going to solve minus 3c squared is equal to minus 6c plus 3. Okay, so what do we have to do first before we even use the quadratic formula? So we've got to make it equal 0. So we're going to add the 6c. Oh, actually, no. You told me something else, didn't you? Add the 3c squared is easier, isn't it? So let's add the 3c squared, gives me 0 on this side, and then 3c squared minus 6c plus 3. Okay, so when I lay out the problem then, I'm going to write down A is, B is, and C is. What's A? 3. What's B? -6, and C is 3. So I write my formula out. I've got it up here. So in this case, it's not x equals, it's c equals. I'm going to do minus b, so that would be minus -6. Oh, yeah. I put it all in, guys. Before I start simplifying, I write it all down because that's the only way I can follow through any mistakes. So plus or minus the square root of, okay, b squared is minus 6 squared minus, and because it's a minus there, I put the next lot in brackets just in case, and it's 4 multiplied by a, which is 3, multiplied by c, which is another 3, okay, all over 2 lots of whatever a is, which is 3. And I just go through and solve that. Simplify it down, okay? So we've got c equals, what's negative? Negative 6. 6. Plus and minus the square root of, well, I've got 36 By the way, not negative 36, which some of you will put when you work this out, because you'll put it into your calculator incorrectly and get negative 36. And although that you will know the answer is not negative 36, you'll still write it down. I know it's going to happen. And that's 36 minus, well, what is 4 multiplied by 3 multiplied by 3? 36. Okay. All over 6. And then simplify one more. So I've got 6 plus or minus the square root of 0. Okay. And then divided by 6. So we end up with C actually being just 6 divided by 6. So C is 1. So how many solutions does this one have? So it has one solution. And what does that mean about the graph? Sorry, I didn't quite get that. Yeah, so if I put a 1 there, I know my curve is going to come down and it's just going to touch at 1 and then go back up. So there is only one solution. So that's fine. All right. So be careful when you use the quadratic formula. Where are the areas of potential slip-ups, guys? Anyone remember doing it and slipping up in certain areas? Yeah, so this bit here, okay, be careful there. This bit also, guys, I mentioned be careful that you don't put a negative, and also be careful there that you use the brackets, okay? It is important, and they are the mistakes. And it's funny because all of the mistakes come from negative numbers. Okay? All right. How does that sound using that formula? It's fine, isn't it? It shouldn't be too much of a problem based on what you've already done. I'm going to introduce already something called, all right, the determinant. All right? So think about what we've just done here. All right, I'm going to introduce something called the determinant. Anyone know what the determinant is? No? What do you think the word determinant means? Yeah, it determines something. All right. So if I tell you that the determinant is b squared minus 4ac, would you have any reasons why that part, okay, so that would be this bit here, why that bit there would be called the determinant? Why would it be so important? Say it again. I think you're right. Yeah, it does. Or no solutions, in fact. So what we can say is if the determinant bit is equal to 0, like we had here, look, we are going to end up with one solution. All right, we are going to end up with one solution. And that's because whatever this is, plus or minus the square root of 0 is it's the same thing. Okay. But we could also have where the determinant is greater than 0, which means it's a positive number, which means here it would, for instance, it might have been 6 plus or minus the square root of 3. So I'm going to have two solutions, aren't I? So I'm going to have 6 plus the square root of 3 with divide, but I'm also going to have 6 minus the square root of 3. By the way, did you all recognize that as like vertex form, what we end up with? I'll take that as a yes. So if the determinant is greater than 0, so it's a positive number, we're going to end up with two solutions. But something we talked about with vertex form, there is another possibility, which is, what if the b squared minus 4ac is actually less than 0, which means we have a negative number. All right, what's the thing there? Say it again. Why? Exactly. Right? This bit here, if you think what we're doing, the determinant, but we would actually be square rooting the determinant. So if the determinant is a negative number, so like the square root of -6, all right, we can't do that, can we? So we know that if the determinant bit is a negative number, we might as well just stop going. So that's why this bit here is actually quite important. We might as well do that bit first. So if I end up with a negative number, I know no solutions, no point worrying about it. Right? Now, the reason why this is quite important is as you progress through these exercises, the problem solving, for instance, will say to you, you know this quadratic has one solution. Find A, B, and C. All right. And you might be saying, well, how does that help me that it's got one solution? I don't know what it is. But what we can do is use this piece of information that this here must equal 0. All right. So we can use that with anything else they give us that will help us find it. All right. So I believe your next phase then is in your textbook, practice 5. Like you can see up here, look, in the examples, the kind of things, giving your answers to decimals and stuff. All right, who's chatting? I don't think we did video Friday's lesson, actually. I did put 4 videos though, didn't I? Did you see those, guys?
It didn't take you, like, there are no
But do you remember I put another comment where I put all 4 videos separately? I'll show you in a second. So you're going to be doing this. You're going to have a look at these using the quadratic formula, solve, giving. Do you know what radical form means, guys? Well, you do. Do you remember?
I don't remember.
Surd form, yeah. Just so leave an exact form we've been talking about. Okay. So you're going to be practicing. Now, to be honest, with the quadratic formula, people overuse it, I think. It's probably easier to use other methods. There's just lots of potential mistakes. So we'll do it a few times, pick a few that you know test your ability, but what you're looking for is ones that you know have one or no solutions, see what happens. But, you know, give it the 40 minutes, the half an hour, 40 minutes on working through these. All right. We don't need to repeat the quadratic formula because it's just a lot of writing. Okay. But then the next bit that we're going to be looking at is this. Oh, they call it the discriminant. Okay. Different word, Americanized, I guess. We're going to be looking at that in detail. Now, if you feel free to go on to that, but that's what we'll consider a bit more next time. But if you're happy with it, you can go on. All right. Now, in terms of the teams thing that I gave to you, let me just show you. So, solving quadratic form. Here's the teams. That's where I put your message. You can see that, yeah? So I gave this link, which you're saying doesn't work for you. Fine. It does for me, but maybe that's my computer setup. But above it, look, I gave you 4 links. So if I click on one of those, what do you see now? Still the teams. So if
the bottomling won't work for us because it's the studio.
Right.
So it takes it to like your actual channel.
Yeah, I guess.
And we don't have edit.
That's probably why then, yeah. But do you see this one then? So those 4 links, what I did with those 4 links is I actually, before last lesson, so this is not the lesson, but I went through right from the beginning. I went, right, these are examples for solving with factorization. And I did a few different examples. So what if the brackets are both positive? What if one's negative? I also spotted in someone's work that they were struggling if the bracket had 2x plus 3 in there. So I did an example like that. And then I also then went on to looking at vertex form. So you might not need all of these, but they have a quick look, find the one that works for you. But of course, you know my the YouTube channel. I did put the link to you very early on. So this channel that you can search for, Mr. Potts How To, it's called. So in the playlist, you've got the M4 ones. Like I said at the beginning, I created a new one that didn't have you guys in it. All right, so it's got all the stuff that we've been working on. So I put those quadratics in factorize, standard form, factorize and solve, vertex form. So you've got those videos to go through if you want. Okay. Any questions? All right, so just in the last minute that I've got, I'll be very quick. Assessment coming up. All right, just to give you a quick idea of what I'm planning. So the modeling one that you did with the basketball hoop, we are going to do something along that sort of lines, but I'm going to give you something to do with a vehicle jumping over a gap. All right, consider the same sort of thing. It's going to be a criterion D, but that is going to be your summative assessment for the end of year thing. All right, make sense? So I'll give you the details closer to the time, but we're talking about an end of year summative assessment. That's it. Before that, I think next week, I've now put a date in for you. I'm going to do a criterion A just on the factorizing and solving and using the formula and vertex form. All right. Now, I'm only going to have 30 seconds. So if you've got any questions regarding that, get on Teams, ask them, let me know, and we can discuss it. But that's basically what your assessment's going to be now for